Okay, my voice is a little messed up um, because I've been sick for the past like week, so ignore that. I mean, that's why I'm recording this. Also, if you hear a cut, it's because I had a coughing fit, probably. Anyways, all right. Hi, my name is Brad, and today I'll be talking about restaurant popularity during COVID. So this project looks at the popularity of restaurants uh, over time, including during COVID, and these restaurants are from Yelp. So restaurants of all kinds took a big hit during COVID, obviously because of the quarantine measures. People just not wanting to go out because they're afraid of getting sick. So it's important to see what kind of an effect this had on restaurants and if any of them were affected disproportionately. For goodness, I can assess the goodness of the analytic by comparing my results to those measured in other papers as well as other data and also researching any causes behind observations that stand out to me. And my results I found generally fit what I saw with other papers and also with common sense. And because all results were measured, all the numbers were measured relative to each other and their average before COVID, the overall popularity of Yelp as a platform didn't affect the goodness of my results. So my data source, like I said before, was Yelp. It's a Yelp dataset. Oops. So this dataset contains reviews and other info about a subset of businesses on Yelp, as well as user data, but I didn't use that part. The parts I did use are businesses. So this has like the business info, so like hours, categories, the states, like the state, the location. There's reviews, there's check-ins, and there's tips. All right, this is my big flow chart. I should get the laser pointer. Okay, so excuse me. So it starts up here at business.json. So first going down, there's the profiling code. All of it is in MapReduce, and it runs straight on the JSON file. So first step to cleaning it is I have to filter business.json and keep only the restaurants. I did this in MapReduce by looking at keywords like food, restaurant, bar, um, and yeah, that gives me a JSON with only restaurants. Then I have to convert that to CSV, which I did using a library called JSON. It's by Google, I think, and it's just a JSON library for Java. Um, I convert that to CSV, and then I load that data into a table in Hive, and that gives me the restaurants table. Now coming back here, we have these three inputs: reviews, check-ins, and tips. All of them JSON. So I use the same library, JSON, and convert them to CSV. Then I load it into Hive. Okay, there's a cut here because I started coughing. Okay, but no, with these three tables, reviews, check-ins, and tips, the first thing I do is I interjoin them with restaurants to basically give me the reviews, check-ins, and tips for only the restaurants. Then I take those three filter tables and I combine them in Hive using Union. The reason I do this is because I want a big table of visits, and all of these three have a date to them. So basically, if I combine them, that's just more data, better results. Yeah, so that gives me the visits table. Now for cuisines, you can see in this arrow. I'll explain further in one of my code challenge slides for cuisines. But basically, I left join restaurants with cuisines, a table called cuisines in Hive, and that gives me restaurant cuisines. And to explain the schema for restaurant cuisines is basically the restaurant info plus a cuisine column. So like if a restaurant was Italian and Chinese for some reason, it would show up twice in restaurant cuisines, once with Chinese, once with Italian. All right, so first analytic is with cuisines. So basically, I interjoin visits with restaurant cuisines. That gives me cuisine visits. And then I group that by cuisine and date. Cuisine is from restaurant cuisines, date is from visits. and then I analyze it by counting visits. Right. The second analytic is I left join visits with the original restaurant table, which has info about which state the restaurant is in. So that gives me state visits, which I then group by state and date, and then I do the same analysis. Right. So first code challenge is actually JSON. So the Yelp dataset, it came in JSON format, which was a lot more annoying to deal with than I thought it would be. I think it's because I was using like the bare bones Java, so like I was building everything on the command line. Um, so I just couldn't figure out how to get any library working for the longest time. I did figure it out eventually, and I settled on the JSON library by Google. It's a JSON library. And I wrote a few classes to represent objects. So you can see there's business, which has like business ID, um, state, categories, hours. There's review, which also has it has a date. Schema also has a date, but this date is actually a list of dates, but it's fine. I figured that out. And there's tip, which also has a date. Right. So now my second code challenge was cuisines. So restaurants came with categories. So these are like fast food, sushi bar, so many bars, so many different types of bars and alcohol. Um, but they weren't clearly defined cuisines. So I had to group categories into cuisines basically. There were like there were hundreds of categories, which I just looked through one by one basically and uh, pasted whichever one's matched a category. Oh, whichever one's matched cuisine into this big list. Excuse me. Um, yeah, so I ended up with this list of cuisines and matching categories. So for example, like let's see, like Japanese would match with Japanese, sushi bars, ramen, and teppanyaki. Right. So having this list, I used it in a MapReduce program to make a CSV with restaurants and their cuisines. My doorbell's ringing, but I think that's my roommate's. Sorry. um, yeah, I made a CSV with restaurants and their cuisines, which I explained earlier. Gave me that restaurant and cuisine table, which I used in my analytic. Okay, moving on to observations for cuisine. So this graph you see here comes from plotting the number of visits for each cuisine since 2019 as a percentage of the pre-COVID average, which gives this graph. Yeah, so pre-COVID average, I counted as 2019. Basically the average visits per quarter in 2019 was the average, and then after that, I plotted the number of visits for each quarter. So first observation is fast food. It takes the smallest hit, losing 48%, less than half of their average visits in 2019. So that's this top line over here. You can see there's a pretty good margin between fast food and the second highest. On the opposite end of the spectrum is Cajun and Creole, which is affected the most, and it loses 87% at its lowest at the first dip, which is which is a lot. Canadian recovers a bit but falls again. So Canadian is this orange line. There's this big dip. It starts recovering, but then it falls again, and then there's just this big dip, and it kind of struggles to go back up. And I do want to point out, I thought it was interesting that Chinese seems to recover a little slower than most other cuisines, most noticeably in 2020 Q3 and 2021 Q2, where other cuisines kind of saw bigger spikes. It's hard to see in the graph. It's dark blue, but I'll explain it. Basically, Chinese in the big dip in 2020 Q2, where all the restaurants dipped, Chinese was solidly kind of in the middle of the pack. But after that, it's always in like the lowest, maybe 4, and that includes Cajun Creole and Canadian, which are special cases. So yeah, I thought it was interesting that it doesn't seem to recover as fast. It's kind of flatter than the rest and the other cuisines. Moving on. Observations for state. First thing to note is that this graph looks pretty similar to the one for cuisines, and there's some key similarities that explain some of the observations above. The first one being Louisiana, which is hit the hardest. It's this green line down here, hit pretty hard. And this lines up perfectly with the Cajun and Creole line. If you go back to the previous slide, this aqua line and this green line are both hit the hardest, and that makes sense because Cajun Creole is native to Louisiana, like New Orleans and whatnot. So it's also where it's the most prevalent. So that's why Cajun and Creole took the biggest hit, because Louisiana took such a big hit. The state that dips later in the pandemic is Alberta, Canada. It's this blue line over here, and that lines up with the Canadian line. So that's self-explanatory. Alberta, Canada, Canadian, right? Anyways, insights. So restaurants were affected greatly by the pandemic. Obviously, they lost well over half of all their customers compared to before COVID. Yeah, and the steep decline from 2020 Q1 to Q2 actually lines up with the stay-at-home orders coming out across the nation, across the US. So this big drop over here is actually when the stay-at-home orders started appearing. So, yeah. Regarding cuisine and location, both of these factors can have an impact on how restaurants fared during the pandemic. For example, fast food predictably suffered the least because it's the most flexible, it's the easiest to transition into like purely takeout. So yeah, that's why they took the smallest hit, which makes sense. But I think the bigger influence overall came from the restaurant's location. So in this case, the state. This is evident with Cajun and Creole in Louisiana and Canadian in Alberta, respectively. So the trend for Canadian reflects how Alberta, the state, failed to recover from the pandemic. And also for Louisiana, and as a result, Cajun Creole, we even see a dip for Hurricane Ida in 2021 Q3. You can see if you follow this green line, it goes up, 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 and then in 2021 Q3, it goes knocked down again. Because the reason being, there was a hurricane in August, I think. So, yeah, clearly, how the cuisines perform are tied in some way to how the state is doing. Right. So that was it. Those are my insights. I thought it was really interesting to see how restaurants were affected, and I didn't expect the Cajun and Creole and Canadian results, so that was really interesting to see as well. Okay, acknowledgements. I want to thank NYU HBC for providing the Peel Cluster. Very sad that it's shutting down after this semester. I want to thank Atlassian for letting me use Jira for free. I want to thank Yelp for providing the dataset, and of course, I want to thank our professor for teaching us. Right, thank you. Oh, these are my references. All right, thanks.